Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. So today I am going to say the topic Introduction to the Mechanisms in the subject Kinematics of Machinery. So first of all, we need to understand what is a mechanism and what is the purpose of a mechanism in this kinematics of machinery. So we are going to see the introduction topics of the kinematics of machinery in this lecture video. So coming to the introduction, so first of all, what is a mechanism? So mechanism can be defined as the number of bodies which are assembled in a way in which that the motion of the one causes constrained or predictable motion to the others. So while giving a mechanism, so when we are going to introduce a mechanism, we need to know about the motion of a constrained and predictable motion. So first of all, what is a motion? So motion means a generated work. So the work generated from one part to the other part is known as motion. So in that we are going to use number of bodies which is assembled as a machine. So in this machine it generates the mechanism by the number of bodies which are assembled together. Then this mechanism transmits and modifies a motion. So depending upon the type of mechanism, it is going to transmit or modifies a motion. Then a machine is a mechanism or a combination of mechanisms which imparting definite motions of parts which are also transmitting the or modifying the available mechanical energy into some kind of desired work or useful work. So we are going to see some useful work by using the available mechanical energy transforming into a useful work. So this is done by purely by mechanism only. Thus a mechanism is a fundamental unit and it has to start with its study. So that is depending upon the type of the mechanism. Then the study of a mechanism involves its analysis as well as the synthesis. So it depends upon the analysis and the synthesis of a part. So first of all, you need to know the analysis of a desired mechanism. So what are the mechanism we are studying or we are designing? So what are the number of links, what are the number of pairs, and what are the number of joints it is involved. So this depends on the study of a mechanism. Next, the analysis is go through the study of motions and forces. So what are the different kinds of motions, that is known as degrees of freedom here. So what are the number of motions carried by the mechanism and what are the concerned different parts of an existing mechanism. So this is used to study the characteristics of a motion, whereas synthesis involves the design of its different parts. So there are different parts considering in the mechanism. So this depends upon the analysis of the study. Next, in a mechanism, the various parts are so proportioned and related that the motion of one imparts different types of motions to the others and the parts are able to withstand the forces impressed upon them. So this defines the various designs of the mechanism and various parts of a mechanism. Next, in this kinematics of machinery, we need to define what is a kinematics and what is a dynamics. So there are two kinds of motion, that is kinematics and dynamics. So first of all, when we are going to study the kinematics, it deals with the relative motions of different parts of a mechanism, which does not involve the forces producing the motions. So here in the first point you can see that it deals with the relative motions of the different parts of a mechanism without taking into consideration the forces producing the motions. So this involves the only the degrees of freedom here, but not the any types of forces. Next, it is the study from a geometrical point of view to know the displacement, velocity and acceleration of a part of a mechanism. So these kinematics involves only the displacement, velocity and acceleration of a part of a mechanism. So this does not involve any kinds of forces, any types of reactions. So it only involves the displacement, velocity and acceleration of a part of a mechanism. Next, going to the dynamics. So this dynamics involves the only the forces calculation which is impressed upon the different parts of a mechanism. So that is depending upon the stature of the body, we are taking some different forces on calculations on different parts of a mechanism. Then these forces can either be static or dynamic force. So there is static force or dynamic force. And these dynamics is subdivided into two types, that is kinetics and statics. So first of all, kinetics is the study of forces when the body is in motion, whereas statics deals with the forces when the body is in stationary. So stationary means when it is in the idle position. So when we are taking a body in the idle position, we are taking it as statics. But when some forces is applied on the body and it is in the motion due to study of forces, it is known as kinetics. So the two differences are kinetics is purely deals with the body motion and statics deals with the body which is in stationary position, that is which is in the idle position. So you need not to be in the regular motion but only in the idle position only. Next, going to the next slide, we are going to define the kinematic link, or it is simply known as kinematic element. So each part of a machine or each part of an assembled machine which moves relative to the some other part is known as kinematic link. So there is definitely some motion in the body. So there is some movement in the body or link or element. So link or element. So link anna element anna rendu ఒకటే నంబర్. సో మన మెకానిజమ్స్ లో కానీ లేకపోతే మెషిన్ లో కానీ ఒక అసెంబుల్డ్ మెషిన్ లో ఒక లింక్ అన్న ఎలిమెంట్ అన్న రెండు కూడా ఒకటే. Next, going to the next point, a link may consist of several parts which are rigidly fastened together so that they do not move relative to the another one. So a link may consist of two joints. So two sides of the part of a link is two joints which are rigidly fastened to move one from the other part. So it is used to transmit motion from one part to the other part. So for an example, in the below picture you can see the reciprocating steam engine. So it has a piston rod and a crosshead constitute, that is only one link, that is known as connecting rod, with big and small end bearings, which is known as the second link here, and the first one link is the piston rod, that is the small end bearing here, and crank shaft, crank and flywheel. So this flywheel is the third link here, and the cylinder, engine frame and the main bearings are the fourth link. So in total there are four links providing here. So first one is the piston and the piston rod, which is used to reciprocate motion, and second one is the connecting rod. Second link is the connecting rod here, which you can see it in the picture. So this is the connecting rod, and one side of the connecting rod is attached to the crank, which is used to rotate clockwise or anti-clockwise. So that depends upon the position of the flywheel. And crank is the third link here. So crank and crankshaft and the flywheel. So these are three are attached to each other, and these are the third link, and engine frame and main bearings are the fourth link. So these are all the four links here. So when we need to transmit the motion from one part to the other, these four links are used to transmit motion from one link to the other link. So that is crank used to rotate and transmit motion from crankshaft to connecting rod, and this connecting rod used to put the crosshead, and next it is used to transmit from the crosshead to the piston rod. So that is the kinematic link here. So each and every element has a kinematic motion. So that is a simple motion which is used to regulate the move the other part. So that is known as kinematic link. Next, we need to see the different types of links here. So in order to transmit motion from the driver to the follower, different types of links has been arranged. So mainly there are three types of links. First one is the rigid link, second one is the flexible link, and third one is the fluid link. So mainly there are three types of links: rigid link, flexible link and fluid link. So coming to the first one, it is a rigid link is defined as it is used to transmit motion, but it does not undergo any deformation. So that is, it is idle in creature. So that is, a structure can be a rigid link. So because there is no any kind of motion in the rigid link. So that is, there is no deformation in the rigid link. So there are not any deformation in the rigid link, which is used to transmitting motion. And these rigid links generally does not exist, because a structure is kind of different types of links, but a rigid links does not exist in single creature. However, as the deformation of a connecting rod, crank of a reciprocating steam engine, it is not appreciable, and they can be considered as rigid links. So they are considered to be as rigid links. Next, second one is the flexible link. So a flexible link is one which is partly deformed in a manner not to affect the transmission of motion. So this flexible link has some motion in it which is used to partly deformed in the structure. So there are different types of examples. So for example, belt drives, rope drives and chain drives. So these are all the flexible links and which is used to transmit the tensile forces only. So these are all known as flexible links. Next, third one is the fluid link. So a fluid link is the one which is formed by having a fluid in a receptacle and as the motion is transmitted through the fluid by pressure or compression only. So generally these fluid links does not exist in the kinematics. So we does not create any loop to find this fluid link here. So there is no kind of fluid links in the kinematics, and it is used in the case of hydraulic presses, hydraulic jacks and hydraulic brakes only. So by using the fluid only it will work. So it is used to transmit motion to the other by using a fluid only. So these are the three types of links: rigid link, flexible link and fluid link. Next one is the link. So what is the definition of the link and what are the different types of links here? So firstly, link is the name given to the any body which has a definite relative motion to the other. So it is the name given to any body which has definite relative motion to the other, and all materials have some elastic property. So which is used to deform its position and change its position. And next, a rigid link is the one whose deformations are so small that they can be neglected in determining the motion parameters of the link. So when we are going to do the work or when we are transmitting the motion, then the link has some deformation in it. So that is a neglectable deformation. So the deformation can be evaluated through the different kinds of parameters. So it is the name given to the body which exhibits the relative motion between one part to the other part. And next, coming to the types of links, there are three types of links: binary link, ternary link and quaternary link. So first one is the binary link. So a binary link is the link which is connected to the other links at only 2 points. So when you can see it in the picture also, first one is the binary link which has two endpoints here. So the two endpoints is the two links here. And coming to the second one, it is the ternary link. So this ternary link has 3 points here. So which is connected to the other links at 3 points. So which is in the triangular position. So a ternary link is the link which is connected to the other links at 3 points. And last one is the quaternary link. So quaternary means 4. So which is used to connect the other links at 4 different points. So you can see it in the picture. A square picture has been enabled to see here at 4 points. So the links has been connected to 4 different points here, and it is known as quaternary link. So these are the 3 different types of links. Next one is the structure. So what is a definite structure? So we need to define the structure. So structure is definitely a rigid link because there is no movement in the structure, but it is an assemble of a number of resistant bodies, that is number of members. So you can see a number of pillars or number of beams in the structure. So all these beams or pillars is known as members here, which has no relative motion between them and meant for carrying only loads only. So they having only straining action, which is used to mean for carrying loads. So for example, a railway bridge or a roof truss and machine frames are the examples of a structure. So you can see it in the bridges, roofs. So when we are arranging the iron roofs or cement roofs, there are structure, and we are seeing it in the machine frames also. So all these are all the examples of a structure. Next, we need to see the difference between the machine and a structure. So first of all, we had seen the what is a machine and what is a mechanism. And next we are going to see the basic difference between a machine and a structure. So mainly there are three main differences. So the following differences between machine and structure are the subject point of view. So first difference is the parts of a machine move relative to the one another. So in a machine, the parts will move, but the members of a structure does not move relative to the one another. So in a machine, you can move the links or joints, but in a structure we cannot move. So the machine is a flexible link, and but the structure is a fixed link. Next, second one is the a machine transforms the available energy into some useful work, whereas in a structure no energy is transformed into the useful work. So definitely a machine will transforms the available energy into some useful work. So it will transform by using different types of links and different types of joints. But in the structure, no energy is transformed into the useful work. And last one, the links of a machine may transmit both power and motion. So in a machine, you can transmit the both power and motion. But in the members of a structure, it is used to transmit forces only. It is used to transmit forces only. So because the structure does not move, so it is the simple reason. But a machine can move by using its different types of parts, and it can transform the both power and motion. Meanwhile, the members of a structure of a can transmit the forces also. So it also can transmit forces only. So these are the main difference between the machine and a structure. Next one is the kinematic pair. So we have already seen the what is a link and what is a kinematic link. Next we use it to see the kinematic pair. So when the two links of a machine are contact with each other and they are said to be form a pair. So in this for a pair there is a relative motion between them is completely or successfully constrained. That is known as a kinematic pair. So if you are taking the two links or two elements of a machine which is contact with each other, and this pair is to be form a pair which is completely constrained or successfully constrained. So these completely constrained or successfully constrained are known by seeing the definite direction, so which involves the motion in a definite direction. So that is known as the successfully constrained motion or a completely constrained motion. So that type of motion when evaluated in two links or two elements of a machine which are in contact with each other. So that type of pair is known as kinematic pair. So the definition is seen here. The first point only, the two links of elements of a machine when in contact with each other are said to form a pair if the relative motion between them is completely or successfully constrained in a definite direction. So that pair is known as kinematic pair. So what are these constrained motions? So before going to the classify the kinematic pair, we are going to know the different types of constrained motions. So mainly there are three types of constrained motions here. So that is, first one is the completely constrained motion. Completely constrained motion. So when the motion between a pair is limited to a definite direction, irrespective of the force applied in the direction, then this motion is called as completely constrained motion. So in this completely constrained motion, the motion is between the pair is on only in a definite direction, that is only in one direction only. So here we are seeing an example here. So a block is filled with the internally drilled with the square hole as the shape, and a square bar is used to fit in the square hole. But when we use it to apply external forces in the square bar to move in the vertical direction, as well as in the other directions, but it will move only on the forward direction, that is on the whole direction only. So which is on the square whole direction only. So that is the main difference here. So the shape is given as square here. So in the square we use it to transmit motion only on one side of the direction only. So that is on the horizontal direction when it is placed in the vertical position. So, for example, the piston and a cylinder forms a pair, and the motion of the piston is limited to a definite direction. That is, piston will move in the upward and downward motion. That is known as reciprocating motion or linear motion. So, రెండుటికి ఒకటేనమ్మా. సో లీనియర్ మోషన్ అన్న రెసిప్రోకేటింగ్ మోషన్ అన్న రెండు కూడా ఒకటే. సో and the relative to the cylinder irrespective of the direction of motion. And next one, in the second picture, the motion of a square bar in a square hole, and we can see it in the third mode also, the motion of the shaft with collars at each end in a circular hole. So these are all the examples of completely constrained motion. So that is used to move only in one direction only. So that is used to basically move in only one direction only. Next one is the incompletely constrained motion. So when the motion between a pair can take place in more than one direction, then the motion is called completely constrained motion. So in the below picture you can see a round hole and a circular shaft, and the shaft can move in variable directions, that is in the multiple directions. So it can move it in the linear position, that is reciprocating motion, or it can move in the cylindrical position also. So there are the more than one directions. So when the motion between a pair can be takes place in more than one direction, then it is said to be a incompletely constrained motion. So the change in the direction of these force may alter the direction of relative motion between the pair. So the best example for the incompletely constrained motion is a bolt and nut. So these can move it in the two directions. One is in the reciprocating direction and another one is the circular motion. So in both the directions we can see the incompletely constrained motion. So a circular bar or shaft in a circular hole can be seen in the figure. This is an example of the incompletely constrained motion, as it may either rotate or slide in a hole. These both motions have no relationship with each other. So this does not have any relationship with each other. These kind of motions is called as incompletely constrained motion. And last one is the successfully constrained motion. So in the successfully constrained motion, the motion between the elements are forming a pair in such that so when a Motion between the elements forming a pair is constrained motion, and it is not completed by itself but completed by some other factors. So these are completed by some other factors. This kind of motion is evaluated in the successfully constrained motion. So in this successfully constrained motion, you can see the evaluated motion between two parts. So that is generated between two constrained motion. So we are considering a shaft here. Consider a shaft in a footstep bearing as shown in the figure. And the shaft may rotate in a bearing or it may move upwards. So these can move. So the shaft may rotate in a bearing or it can be moved upwards. So this is a case of incompletely constrained motion. And when you see in the load is placed on the shaft. So when the load is placed on the shaft to prevent axial upward movement, then the motion of the pair is said to be successfully constrained motion. So you can see it in the picture also. A load is applied on the shaft which is on the footstep bearing. So then it is preventing the axial upward movement or downward movement. Then it is known as successfully constrained motion. Next one, the motion of an IC engine valve and the piston reciprocating inside an cylinder are also the examples of successfully constrained motion. So these are all the different examples of the successfully constrained motions. So these are all the different developed factors of a different types of constrained motions. So we can see it in three types. First one is the completely constrained motion, which is applied on the only one direction. And second one is the incompletely constrained motion, which is applied more than one direction. Third one is the successfully constrained motion, which is applied on one direction. So these are all the different types of constrained motions evaluated in the types of mechanisms. So there are different types of mechanisms applied to it. So in the next class, we are going to see the different types of kinematic pairs. So we have already seen what is a kinematic pair. So we are going to classify the kinematic pairs and what are the types of kinematic pairs. So there are different types and the kinematic chain. Different types of kinematic chain. Thank you.